In this video, we're going to be talking about area of a sector and arc length. We're going to start off by talking about the area of a sector. So area of a sector means we are finding the area of just part of a circle. So we've already learned how to find the area of a whole circle, and now we're going to be able to find the area of part of a circle. There's a formula that we're going to use to do this. The formula is right here. Area of the sector is equal to theta over 360 times pi r squared. Now, the pi r squared should look familiar to you. That part represents the area of the whole circle. That's where we've seen that formula before. A equals pi r squared is area of a whole circle. But since we're not finding the area of the entire circle, and we're just finding the area of part of the circle, that's where this first part of the formula comes in. So circles have 360 degrees, okay? So that's how many degrees in a circle. And this theta symbol on top, that's going to represent the central angle. Because the central angle is going to tell us what portion or how many degrees of the circle are we trying to find the area of. This 360 is constant. It will never change. It always stays, just like pi. So let's put this to use. This first example is asking us to find the area of the sector with the central angle given. So we have a picture here. Central angle given here is 150 degrees. And they also give us the radius. The center to the edge is 10 meters. So using the formula above, I'm going to put the central angle over 360. So in this case, 150 degrees over 360 times pi r squared. R, the radius, in this case is 10. So pi times 10 squared. So depending on what calculator you have to use, I'm going to show you on this calculator, but you might have to play with whatever calculators you have available to you just until you can get the same answer. Now, just like when we did area and circumference, I'm going to ask you to do exact and rounded answers. So to recall, exact answers, we're not typing pi in the calculator. And for rounded answers, we are typing pi in the calculator. But for exact, if I don't type pi in the calculator, it must be part of my answer. So I'm going to type in parentheses 150 divided by 360. And then the other set of parentheses, since I'm not typing in pi, it's just 10 squared. And I'm going to hit enter. Now, that does not look like an exact answer to me. If I were to leave that as a decimal, I would have to be rounding. And in exact answers, we don't want any rounding. So we want to make this a fraction. So on my calculator, to make that a fraction, I'm going to hit math, enter, enter. And now that is an exact answer. So an exact answer is 125 over 3. Don't forget pi because it was not put in the calculator. And since we're dealing with area, it's going to be the units, which is meters, squared. So that's the exact answer. We typed in everything but pi. We got a decimal, but we're not rounding. Exact answer should not be rounded, so we want the fraction. Now, to get rounded, you can either retype this whole thing in the calculator with pi, or if you have a calculator like this where you still have the exact answer, you can just hit times pi, because that's the only thing you were missing. If I hit enter, the rounded area is about equal to 130. I'm going to round to the 10th place, so 130.9 meters squared. So I have an exact answer, and I have a rounded answer. Let's look at another one. So number 2 says find the area of the sector. It says it has a diameter of 21 centimeters and a central angle of 189 degrees. So again, I'm going to use the formula for area of a sector. Central angle, 189 degrees. So it's 189 over 360. And then we have to do pi r squared. But in this problem, they did not tell us what r is. They told us the diameter. Remember, diameter is all the way across a circle through the center, edge to edge, and radius is just from the center to the edge. So if they give me diameter, to get the radius, I have to cut the diameter in half. So my radius here is going to be 10.5. So that's the number that I will be plugging in for radius. So again, two answers, exact and rounded. For an exact answer, we don't type in pi. So I'm going to do 189 divided by 360 in parentheses. No pi, but 10.5 squared. And again, I'm getting a decimal. And for exact answers, I don't want decimals because they're not exact. So I'm going to make this a fraction. I'm going to hit math, enter, enter on my calculator. I'm going to get 9,261 over 160. We didn't type pi in, so it is still part of our answer. And the units here were centimeters squared. For rounded, you can retype this whole thing with pi, or if you still have this exact answer in your calculator, you can just hit times pi. And again, I'll round to the nearest tenths. I'm getting about 181.8 centimeters squared. For the next example, we're still using the same formula, but it's going to be asking us for some different information. So number 3 says a sector of a circle whose central angle is 150 degrees has an area of 140 meters squared. Now it's asking us to find the diameter. So it's not asking us to find the area of a sector anymore. I still need to use the area of a sector formula. So I'm going to rewrite just the formula out right now since it's not on the screen anymore. And now we have to plug in the information we know. They said the area of the sector was 140 meters squared, so I'm going to plug in 140 for A. They told me that the central angle was 150 degrees, so I'm going to plug that in for the central angle. They did not tell me anything about a radius. In fact, they're asking me to find a diameter. So I can't plug in anything for R. What I need to do is solve this equation to get R by itself. Because once I know a radius, it's easy to find the diameter because the diameter is twice the radius. So there's a few different ways that you can go about this to get R by itself. Okay, you might be able to do it in fewer steps than me, but I'm going to show you the way that I do it. So first, I like to get rid of this fraction, 150 over 360. So to move this to the other side, multiplying by a fraction, the inverse is multiplying by the reciprocal. So I'm going to multiply both sides of this by 360 over 150. So that means since these are reciprocals, they will cancel on this side. And over here, I'm going to have 360 over 150. So in my calculator, I'm going to do 360 divided by 150 in parentheses. Then I'm going to go times 140. And I'm getting 336. On the right side, I still have pi r squared left. I did not do anything to those yet. Well, pi is being multiplied by r squared. The inverse of multiplying is dividing. So I'm going to divide both sides by pi. So 336 divided by pi is going to give me about 106.95 is about equal to our radius squared. It might look like r is by itself, but it's not yet. There's still that squared we have to get rid of. The inverse of squaring something is square rooting. So I'm going to square root both sides. So I'm going to square root 106.95. And I'm getting about 10.3 as my radius. Now, I can't stop here because the question did not ask for a radius. It asked for the diameter. So remember, diameter goes all the way through the circle, through the center, from edge to edge. So to get the diameter from the radius, we have to double it. So we're going to do 10.3 times 2. So when I do that, I am getting about 20.6, and the units in this problem were meters. I'm not going to put meters squared here because it's not an area. The diameter is just a distance. All right. So 4 is similar. I'm going to go to number 5. So number 5 says, what angle would be the central angle? So now we're looking for a central angle. If the area of the sector was 76.5 centimeters squared and the radius was 5.6 centimeters. So again, we're using the area of a sector formula. I'm going to write it out again. And we're going to plug in the information we know. We know that the area of the sector is 76.5. So I'm going to do 76.5. It's asking what would the central angle be. So I don't have anything to plug in for the central angle. So I'm going to leave that as missing. Here, pi r squared, they did give me the radius this time. So it's pi times 5.6 squared. So now our goal is to get theta, or the central angle, by itself. Again, there are a few ways to do this. Here's my recommendation as to what I'm going to do first. Now you have to be very, very careful when you're doing this. So first, I like to get rid of fractions. You don't have to go in this order, but that's what I'm doing. So if the angle is being divided by 360, I'm going to multiply both sides by 360 because those are inverses and they would cancel. So I'm going to do 360 times 76.5. And that's giving me 27,540. I still have the missing angle, and I still have pi times 5.6 squared. So now we can move this over, okay? So now that we're moving this over, it's being multiplied by pi 5.6 squared. So the inverse of that would be division. But we have to be very careful with how we'd write that in our calculators. So I'm going to divide both sides by pi 5.6 squared. But just like we did in another video or with other topics, when you're dividing by two things, you have to keep it in parentheses. If you do not, you will not get the same answer because your calculator does order of operations, and I will show you the difference in a second. So the correct way to type this in would be 27,540 divided by parentheses pi 5.6 squared. That's giving me a central angle measure of about 279.5 degrees. Remember, angles are measured in degrees. Now, if I did not put the parentheses, and I just did pi 5.6 squared, there's a big difference in my answers. The other way you could do it if you're really worried that you're going to forget the parentheses is do it in two steps. So I could do 27,540 and first divide it by pi, and then after that divide that answer by 5.6 squared. And that will give you the same answer that we got. So if you did this in two steps, divided by pi, then 5.6 squared, that would also work. But if you're going to do it in one step, you cannot forget those parentheses. So now we're going to move on and look at this side, arc length. So arc length, we have a formula that we're going to use. It's S equals, again, we're going to have theta over 360. But now it's going to be multiplied by 2 pi r instead of pi r squared. So arc length, okay, that's going to be the distance around part of a circle. So we previously learned that circumference was the distance around the entire circle. And now we want to find the arc length, which is the distance around part of a circle, which is why part of this arc length formula will look familiar to you. 2 pi r, we learned, is the circumference of a circle. But since we're not finding the circumference of the entire circle, and we're finding the circumference of just part of it, that's where the first part comes in, and it's similar to the first formula. Since there's 360 degrees in a circle, we want to know, this means central angle. Well, what part of that circle are we trying to find the circumference of? Okay. So we're going to do a few examples like this. So if I look at number 1, it's asking us to find the length of arc BA. Okay? So I want to know what this distance is, which is called an arc length. So the arc length formula is right here. So I'm going to plug in what we know. We know the central angle in this case is 50 degrees. So it's going to be 50 over 360. And then 2 pi r, the radius they gave me here was 4. So just like for area of a sector, I'm going to want exact and rounded answers. So for exact, we're going to type in everything except pi. So parentheses 50 divided by 360, parentheses 2 pi 4. Again, we're getting a decimal. Remember, for exact answers, we don't want decimals. They're not exact. So I'm going to make that a fraction. Oh, I just realized my mistake. I did type in pi for an exact answer. Mrs. Kame did not follow her own instructions. So 50 divided by 360. And then instead of pi, since it's exact, we wouldn't do 2 pi 4. It would just be 2 times 4. My apologies. We are still getting a decimal that we don't want. So we hit math, enter, enter. And we will get an exact answer as a fraction. So 10 over 9. We're going to keep pi in our answer. They didn't tell me units here. So if they don't tell you units, just write units. These would not be units squared because it's not area, it's a distance. So there's no squared units. Now, for the rounded answer, you can retype the whole thing in. Or if I just hit my exact answer and I multiply it by pi, I'm getting my rounded answer to be about equal to 3.5 units. Let's do another one like that. So if I look at number 3 from the notes, find the length of the arc, of the bolded arc. So this right here is the bolded arc. So I want to find that length. So I'm going to plug in what we know. The central angle is 225 degrees over 360. And then we're multiplying it by 2 pi r. R in this case, radius is 17. We're going to want exact and rounded answers. So exact, Mrs. Kame is not going to make the same mistake this time. She's going to remember not to type in pi. So 225 divided by 360. And for exact, we're not typing in pi. So in the second parentheses, it's just 2 times 17. Now, this is not a never-ending decimal, but I still would like it as a fraction. So I'm going to hit math, enter, enter. And for my exact answer, I'm getting 85 over 4 pi. In this case, they did give me units. It is yards. To get the rounded answer, we take that and we multiply it by pi. And so if I'm rounding to the nearest tenth here, my rounded answer is about equal to 66.8 yards. Now, just like before, we're going to have some problems where they ask us to find things that are not just the arc length. So when I'm going here, number 5 was missing some information, so we're going to skip that. We're going to look at number 6. It says the length of arc, JK, is 4 centimeters. Find the radius. So I'm going to write the arc length formula so we can use it. So it tells me the length of arc JK is 4 centimeters. That's arc length. So I'm going to plug in 4 for arc length. Now if I look at this picture, 104 degrees is the central angle. Okay? It was just typed, it wasn't the printing, it wasn't in the circle. So 104 degrees out of 360. We're finding the radius, so I don't know what r is. That's missing. So I have to solve this equation to get r by itself. So, similar to the area of a sector, I like to get rid of my fraction first. Well, the inverse of multiplying something by a fraction is multiplying by the reciprocal. So I'm going to multiply both sides by the reciprocal, which is 360 over 104. So over here I'm going to do 360 over 104. So over here they cancel, and then my calculator, I would type in 360 divided by 104 times 4. And I'm getting this really long decimal, okay? So if I hit math, enter, enter, I'm going to get a fraction. So this gives me 180 over 13 is equal to 2 pi r. So now we have to get rid of the 2 pi. Okay? So, again, there's a couple ways to do this. You can do it in 1 step or 2 steps. I'm going to divide both sides by 2 pi, but remember, when you divide by more than one thing, you need parentheses. Now, you might look on this side and say, well, you know, I'm looking at this, Mrs. Kamen, I have a fraction. I can't divide it by another fraction, which is true. If you're dividing, it's on the bottom. So down here, I'm going to just put 2 pi on the bottom. So typing this in the calculator is a bit tricky. So I'm going to do 180 divided by, in parentheses, 13, parentheses, 2 pi, parentheses, parentheses. And I'm going to hit enter. And I get my answer is about 2.2 for my radius. You don't want your radius as a fraction. So my radius is about 2.2 centimeters. Okay? You have to be careful here. Let's do another one. So another example, number 7 in your notes, says, find the central angle if the radius of the arc is 6 meters and the arc length is 12.3 meters. So again, I will write the formula. Plug in what you know. Arc length 12.3, that gets plugged in for arc length. Central angle is what we're finding, so we don't have something for that, so I'm going to leave that as missing. The radius they gave me is 6. So, again, as I said, there's many ways to solve and get the central angle by itself. I'm going to go through and get rid of the fraction first. So the inverse of dividing by 360 is multiplying by 360 on both sides. So now these would cancel. So I have 360 times 12.3, 4,428 equals, I still have theta, the missing angle, and I still have 2 pi times 6. So the missing angle is being multiplied by 2 pi 6. So the inverse of multiplication is division. We're dividing by more than one thing, so we need parentheses when we divide. So when I type this in, I need 4,428 divided by parentheses 2 pi 6. And I'm getting the central angle to be about 117.5 degrees. For my angle. So in this video, I did an example of at least one of every type of problem you could see. Some of you might be using different calculators at home. Maybe it's your phone, maybe it's an online one, maybe it's a scientific. The answers that I got were correct. So play with the calculators that you have until you can get the same answers that I got. If it's not working out, please contact me or whoever your geometry teacher is. We will try and work that out for you.